Kia ora Year 12 and Year 13. This is another question from the 2010 Scholarship Calculus paper, and it's a really good one for going over the benefits of reading a question really slowly. So in here we're asked to prove that the length L of a tangent line from an external point, PQ, to the circle, given by this equation, is given by this expression here. And often in scholarship calculus and other difficult maths situations, if you can see a simple technique to use, it can simplify the problem hugely. And the thing to spot in here is when you look at that expression and you see that square root sign, there's something from back in Year 10 that should pop into your brain. And that thing, of course, is Pythagoras. Okay, so if you do this question using Pythagoras, it's not too bad. So think about, what do we need for Pythagoras? Well, we need to have a right angled triangle. The very first thing we're going to do is to take this mucky equation for a circle and get it into a form where I can easily identify the circle's centre and the radius of the circle. So the basic form of the equation of a circle is this. I think I've done some old conics videos if you want to have a bit more look at that. But to get an equation like this into a form where I can identify the centre, I need to complete the square. So the first thing I'm going to do with this thing is write out that expression. Right, so I've got the, and I'm going to go quite slowly through this. So if you've done lots of scholarship questions already, just skip through this bit. I'm going to reorder the terms to get the X stuff all together. Whoops. And then to get the Y stuff all together. So that's step one. The next thing I'm going to do is do level 2, completing the square on each thing. So the way that I do that is that I say, well, I've got X plus G squared. Now that's going to match up those two terms, but I've accidentally added in G squared. So I take it out. I'm going to do the same thing on the Y bit. So Y plus F squared, take out the F squared. Right? If you're not confident with that, go do some work on completing the square, because it comes up over and over and over. So there we go, X plus G squared plus Y plus F squared is equal to G squared plus F squared plus C. So we're just about good to go. The centre of the circle is going to be at negative G, negative F, and the radius will be, well, I guess the radius itself will be the square root of that stuff. Right, so what we've tried to do there one more time is to get my circle into the basic circle form, which is this, but this is for one where the centre is at 0, 0. So our circle is not centred at 0, 0. It's centred at negative G, negative F. Now, what we're asked to do is to show that the length of the line from somewhere, PQ, to the circle is equal to blah, blah, blah. So going back up to the question, we've rewritten our circle, and now we're up to this bit. We want to show the distance from this point PQ to that circle. And we're told to draw a diagram to support our answer. And even if we hadn't been told that, we should do that. So I'm going to draw a bad diagram. And then I'm going to show you a lovely diagram that I've done in GeoGebra. So we know the circle is centered at negative G, negative F. So it's somewhere down here in this quadrant. We don't know anything about how big it is. So let's just draw it like this. And we've got some other point PQ. Now I'm going to chuck that up here. What we want to do is to find an expression for the distance from PQ to the point where it touches the circle. Okay, now we're also told that it's the tangent line. If you'd spotted Pythagoras in here, you'd now be looking for a right angled triangle, and I think it's pretty easy to see where you're going to get one. If you remember Year 10 geometry, the tangent line is perpendicular to the radius, and that's going to give me a right angled triangle. So here it is here. Actually, this is not looking so terrible as my bad drawings go. So there's our right angled triangle. And once you see that, this question gets really, really easy, especially when I get rid of some of the muckier parts of that little picture. Let's see if it still works. So my circle was here. The length that I'm looking for, L, is here. This point is really easy. This point is negative G, negative F. And this point is PQ. So we don't have to figure out what that point is, which is a good thing because that turns out to be very annoying. What we've got to do is to use Pythagoras on my right angle triangle. So here comes the nice GeoGebra picture of it. There's your right angle. And you can see from looking, this is length L here. The first thing that we're going to get is length AC, right? And that length AC is pretty easy to find because we know those two coordinates. So this is PQ here, and this is negative G, negative F here. Just forget about the numbers on there. The numbers are rubbish. The last thing I've got to do is to find this distance here, but that's easy because it's the radius. So let's let A be point PQ, and B can be the centre of the circle, negative G and negative F. So what can I say? Let's draw out Pythagoras again. This is my length here. This is point A here, and this is point B here, and we don't care about those coordinates. Now, we can say by Pythagoras, A squared plus B squared is equal to C squared. This is A, this is B, and this is C. Now, A squared is just going to be my radius squared. So we can say R squared plus L squared, the thing that I'm after, is equal to C squared. But C squared is easy to get because we know the coordinates of those two. And it's going to be P, point P minus negative G squared plus Q minus negative F squared. So we're just doing Pythagoras between those 2 points. And R squared is coming from my equation of the circle. So that gives me this. L squared is equal to P plus G squared plus Q plus F squared minus R squared. So L squared is equal to this stuff. So that's G, not Q. Now, what was R squared? Well, R squared was the right-hand side of my circle equation. So G squared plus F squared minus C. So you can see that we're getting very close to the end of the problem. All I have to do now is to expand out all of those brackets. And lots of stuff disappears. So the last step is to take square roots of both sides. And that's probably fine, but we're going to make it even more beautiful and get it into exactly the order we were asked for in the question. So P squared plus Q squared plus 2 P plus 2 FQ plus C as required. So there you go. I'm sorry if that was a little bit too slow for some of you, but I'm sure if you're one of those people that you've just skipped right through to the end and you can't even hear me saying this. Thanks for watching. Leave me a comment if you've got any questions on that problem.